Welcome to the Angular Data Grid component tutorial. In this video, you'll learn how to build a real-time hospital patient management system using observables to communicate with a server. I will also demonstrate how to bind data from a custom Angular service to the Syncfusion Angular Grid using the grid's client-side events. First, I'll open my existing Angular application, where I have already added the basic code to render the data grid component. If you want to learn how to get started with the Angular Data Grid, check out the video linked in the card or description. Now I run the application using the command ngserve. What you see now is the output of the starter code. Here, I have loaded the data from a local data source file and displayed only the selected columns in the data grid. Also, you can see the built-in toolbar items added to the grid. You can now edit and save any of the records directly from the grid. Next, I will show you how to perform CRUD operations with observable data on the grid using a real-time hospital patient management system. To begin, I will modify the data.ts file in the application. Here, I plan to create a mock database containing patient details. This file will act as a temporary backend service, returning patient records just like a real data. I import in-memory DB service from the Angular in-memory web API package. This service intercepts HTTP requests to serve as mock data without needing a real server. Next, I define a patient interface to model the hospital patient records. This interface includes fields such as patient name, age, gender, assigned doctor, specialty, diagnosis, and current status. Below the service, I define several reference data arrays, including patient names, doctor names, medical specialties, diagnoses, genders, and patient statuses. These datasets help make the mock data more realistic and varied. To generate the patient records, I use the generatePatients function. This function loops through the specified count, creating a new patient object for each iteration. Finally, I create a class called dataService that implements in-memory DB service. This service provides mock data whenever the application makes HTTP requests. Inside this class, I implement the createDB method, which generates 200 mock patient records by calling the helper function and returns them as a collection of patients. The service also includes a genID method. This method automatically generates unique IDs when new patient records are added. Together, these utilities give a complete reusable mock database that behaves like a real API. Next, I navigate to app HTML file. Here, I will update the app HTML file with column details to display the patient management dashboard. Now, I have configured the columns using an ng template to enable color differentiation based on the information provided in each column, resulting in a cleaner output for the user. The patient ID, patient name, age, doctor name, and specialty columns are configured to display essential patient and doctor information, with validation applied where needed. The gender column uses an ng template with color-coded labels, making it easier to identify gender values at a glance. Similarly, the diagnosis column displays different medical conditions using colored tags, improving readability and visual distinction. Finally, the status column uses a custom template to highlight patient statuses such as active, discharged, and critical with different colors, helping users quickly understand each patient's current condition. In this example, I will set the patient ID field as the primary key to ensure that no duplicate ID values exist across records. Next, I will navigate to the styles CSS file and add style variables for the different fields defined in the columns using ng template. Now, I'll start configure the code to add a new record using observables. I have already created a file called CRUD-service-ts with the required basic code. To add a new record, I will first open the CRUD-service-ts file. Then, I need to import the dataSourceChanged event args type from the Syncfusion EJ2 grids package. Next, I will define a method called addRecord, which returns an observable. This method accepts a parameter named state of type dataSourceChanged event args, which contains the data required to add the new record. I will navigate to the app.ts file. Here, I have configured the initial setup based on the new data structure, such as defining validation rules for specific columns like name and age. These rules ensure that proper input is provided when adding or editing records in the grid. Next, I will implement the dataStateChange method. First, I import dataStateChange event args from the Syncfusion Angular Grids package. In the ng-oninit method, I will implement the dataStateChange method. Inside this method, I will pass the updated state as a parameter to the execute method of the CRUD service. This method is triggered whenever there is a change in the grid state, such as paging, sorting, or filtering. In the app HTML, I bind the dataStateChange method with the dataStateChange event handler. I will navigate to the app.ts file. I will implement the dataSourceChanged method. This method is responsible for handling CRUD operations triggered from the grid. First, I import dataSourceChanged event args from the Syncfusion Angular Grids package. In the export class, I define the dataSourceChanged method with state as its parameter. Inside this method, I use a switch statement to identify the action being performed using state action, or state request type. For the add action, I will call the add record method from the CRUD service, passing the state as a parameter. I then subscribe to the response to ensure the operation is completed. After the record is successfully added, I call the endEdit method on the grid to close the edit form and refresh the grid with the newly added data. Now moving on to the edit operation, I open the service file and define an update record method, which uses the HTTP put method. This method accepts the same parameters as the add record method, except that the state data object contains modified data. I will navigate to the app.ts file. In the dataSourceChanged event, I'll add another condition to check for the edit request type. Inside this block, I subscribe to the observable returned by the update record method, and again call the grid's endEdit method to reflect the updated data in the UI. To handle the delete operation, add a delete record method in the service file. This method retrieves the selected record's ID and sends an HTTP delete request to remove it from the data source. Then it returns an observable containing the server response. To trigger this method, I will navigate to the app.ts file. Add another condition in the dataSourceChanged event to check for the delete request type. Inside this block, I subscribe to the observable returned by delete record and call endEdit to refresh the grid UI with the updated data. In the app HTML, I bind the dataSourceChanged event with the dataSourceChanged event handler. This is how you handle CRUD operations with observable data binding in the Angular grid. Let's check the output. I select a record, click the Edit button from the toolbar, modify a value, and click Update. Changes are saved successfully. To delete a record, select it and click the Delete button from the toolbar. The record will be removed from the grid. In this video, you learned how to perform CRUD operations using observables and use them with the Syncfusion Angular Grid component. You also learned about the dataSourceChanged event and how to bind this custom service to it to handle CRUD operations. If you want to try out the example used in this video, download it from the GitHub link in the description below. I have also shared a link to learn how to obtain a free license key to use our Angular components through our community license if you are eligible. Thank you for watching this video.